Friends, welcome to another video, video number 2 of the series of preparing for your paper 2 grade 10 exam, and all the topics, going through all the topics that you do get in paper 2. I've done a video just prior to this on data handling or statistics, and now I'm going to do one on analytical geometry. So if you are preparing for paper 2 and you just want to be reminded of everything you need to do with analytical geometry and look through all the past questions that I've had in exams, this is the video for you. So if you walk with me, at the end of this you've got analytical geometry covered. All right, so this was a question 2 from a past exam. In the diagram below, PQRS is a kite with P, then they give you all the coordinates. Just make sure that they don't give something in the write-up that hasn't been depicted in the picture. They say to you that PQ is equal to QR, which we know of a kite. Hey, adjacent sides of a kite are, 2 pairs of adjacent sides are equal, and the diagonals intersect at A such that PA is equal to AR. All right, so just noting that this is also the same, which makes A the midpoint between P and R. All right, we know also the angle at A is 90 degrees, but that's just an add-on. the diagonals bisect each other at 90 degrees. Okay, now they say to you, write down the coordinates of A, the midpoint of PR. So again, they even reiterate there that it is the midpoint. Okay, and the midpoint is when you've got x2 plus x1, so that's the 2x values. Again, you don't have to write down, I'm just writing to what's given to you on your formula sheet. So the midpoint is the 2x values added together. So 8 plus 3 is 11. 11 divided by 2 gives you 5.5. So that would be the x coordinate over there, the x part of the coordinate, and the y value is 5 plus 0 divided by 2 gives you 2.5. Okay, so whether you wanted to write it as 5.5 like that, or 2.5, or 5.5, 2.5, it doesn't matter. All right, that was quite easy. Calculate the gradient of QS. So QS over here. Okay, I like to just always write down the coordinates that I'm working with. So Q is 9, 6, and S is -1, -4. Okay, and the gradient is the change of y over the change of x. They also give it to you as let me just write the complete formula. On your formula sheet, they will tell you m is equal to y2 minus y1 over x2 minus x1. Okay, so let's get to the gradient. Change of y, so I'm going to start over here, 6 minus, be careful for your double negatives, minus 4 over 9 minus what? Minus 1. 6 plus 4 is 10, over 9 plus 1 is 10, which gives you a gradient, a +1. And is it a positive gradient? Yes, it is. It is going from left to right. It's going up. So it could be that, or it should be that my gradient is 1. Okay, show that PR is perpendicular to QS. So PR, so again, just because I'm going over from page to page, I just want to write P and R's coordinate, 3, 5. P and R is 8, 0. And Q and S, can you see QS? I've already worked out QS's gradient, so I'm not going to do that again. Basically, what I want to do is I want to work out the gradient of PR. And then, remember, if the gradient of the one times the gradient of the other gives me -1, it means that they are perpendicular. Okay, so we already have the gradient of QS. So now the gradient of PR is change of y over change of x. So please remember, if you start here, 5 minus 0 over 3 minus 8. There's no double negatives that I have to be careful for. And 5 minus 0 is 5. And 3 minus 8 gives you -5, which gives you negative 1. So then we can say that the gradient of PR times the gradient of QS is equal to 1 times negative 1, which gives me that negative 1. Thus, PR is perpendicular to QS. Okay, hope it makes sense. Okay, then they say to calculate the distance of QS and PR. Round your answer off to the nearest 2 decimal places. Okay. For question D, calculate the distance of QS and PR. So again, just for my own reference, I went and I wrote down just the coordinates again. And the distance formula they give you, it's the 2x values subtracted plus the 2y values subtracted. Oh, you know, that's a big mistake if I do that. Okay, all right. So the 2x values, it's 9 minus 1. And the 2y value subtracted, 6 minus 4. Which gives you the square root of 9 plus 1 is 10. 10 squared is 100. And 6 plus 4 is 10. 10 squared is 100. Which is the square root of 200. And again, remember they ask you to round off to the nearest 2 decimal places, which gives you 14,14. All right, let's look at this one. So please remember to practice this because you do get out of practice a bit as well. Okay, so the 2y value subtracted, 3 minus 8, and the 2y value subtracted, 5 minus 0. 3 minus 8 is negative 5. Negative 5 squared is 25. Plus 5 squared is 25. So the square root of 50, rounded off to the nearest 2 decimal, is 7,07. Okay, hence calculate the area of the kite PQRS. Okay, so now this is a lovely question. PQRS. How do we find the area of a kite? Now, people, this is very easy. It's 2 triangles. And you know the triangles area is half times base times height, or base times height divided by 2. Okay, so I'm just going to redraw my kite so that I can give you a better picture of what I'm doing. It was lying something like this. And then, let me just redraw that. Oh, sorry. Okay, short, long, and then again it looks horrible, sorry. I just went and I redrew it a bit and then I put in the distance that I had. Okay, so you can, remember it's with a triangle, it's your base times your height, and it's the base and the height always meets perpendicularly. So if I had to break it up into 2 parts, I'm going to do it like this, which will make this part my 90 degrees. And the other part of the triangle will look something like that. And there's my other 90 degree. So now, do we have the base? Do we have the height? Yes. The base in both instances is 14,14. And the base, the height in both instances is 7.07 divided by 2. Which gives you 3,535. I'm just going to keep all the digits to remain more accurate. Okay, so it's your base times your height. So can you see how I got that perpendicular height? It was 7.07, but they did tell me in the beginning, if I didn't know that those 2 sides are equal. So your base for both triangles is 14.14, which runs through here. And then your height, I took that 7.07 and I just divided by 2. Okay, but can you see it's 2 congruent triangles? So I just need to work out with 1, and then I'm just going to multiply my answer by 2. So base times height divided by 2. The base is 14,14 times the height. And then I'm going to divide it by 2, so I'm going to go the long route. So that times 14.14 divided by 2 gives you 24,99245. But now I'm going to times it by 2 because there's 2 triangles, which gives you 49.98. If I had to round it off to the nearest 2 decimal place, but if there's no instructions given, no, it says under D, calculate to the nearest 2 decimal places, so let's stick to that. So this will be units squared. Okay, all right. I hope you understand that. So it's base times height. I worked out the 1, and because these two are exactly the same, I just times it by 2. Now they say to you, prove that triangle PQR is an isosceles triangle. Okay, let's quickly go look. Where is PQR? PQR. Okay, although they've given me that those two are the same, PQ is equal to QR, they are saying to you, prove that they are equal. Prove that it is. Okay, so although they've given it to me, I'm going to carry on and prove that they are. So what you can do is you can work out the distance of QP and see if it equals to QR. So QP, distance of QP is equal to the distance of QR. And if I have those coordinates, I'm just going to quickly write it down again. Okay, there we go. Distance of QP is equal to the distance of QR. I've got all my formula. So the distance of QP I'm going to work out here. Okay, the 2x values subtracted and the 2y values subtracted gives you 9 minus 3 is 6. 6 squared is 36. Plus 6 minus 5 is 1. 1 squared is 1, which gives you the square root of 37. I'm just going to keep it in that format. And then over here, the distance of QR. The 2x value subtracted, and then the 2y value subtracted is equal to 1 squared, which is 1, and 6 squared is 36. Which equals the square root of 37. So thus, QP is equal to QR. Okay, not so hard. Hope not. All right, let's look at this question over here. Okay, given below in the diagram is triangle A, B, and C, with A -2, 8, B 2, 6, and C -1/2, -4. P is the midpoint of BC over there, and determine the equation of line BC. Okay, so for BC, I first want to find the gradient, which is change of y over change of x, which gives you 6 plus 4 is 10, over 2 plus 0.5, which gives you 2.5, and 10 divided by 2.5, just want to make sure, is 4. Okay, so now I've got y is equal to 4x plus c, and again I've got my gradient, so I'm just going to pop in a coordinate back in here, with the y value is 6, the x value is 2, and I can find through that my c's value. So 4 times 2 is 8. 6 minus 8 gives you c is equal to -2. So we just want to go make sure. Can you see it goes through the y-axis there at a negative? So I'm sure that I am definitely on the right path. Okay, so y is equal to 4x minus 2. Okay, determine the coordinates of point the midpoint of BC. So point P is the 2x values added together divided by 2, and the 2y values, sorry, I didn't add 1 or 2 now, but you get my drift. Okay, so the 2x values is 2 plus minus a half divided by 2, and the 2y values 6 plus minus 4 divided by 2. which gives you P's coordinate. 2 minus 0.5 gives you 3 over 2 divided by 2 gives you 3/4. And 6 minus 4 divided by 2 gives you 1. Let's just see if that makes sense. If P over there gives you 3/4, if that one point there is 2, luckily 3/4 is less than 2, and 1 is a positive. Yes, okay, so it makes sense. Q is a point on AC such that PQ is parallel to AB. So Q is a point on AC such that PQ is parallel to AB. So it will look sort of something like that. Let me just make it bigger. So Q is a point on AC such that PQ is parallel to PQ. Determine the equation of PQ if P's coordinate is, yeah, they give it to me, 3/4 double that one. Okay, so whenever they tell you this is what P is, or just go back to your question and just go see whether you got that. Okay, and most likely it's just because of the follow-up marking, and so that your working out shows or carries on correctly, that the teacher will give you what the point should have been. So when you just go back, just go look, is that what you got? Yes. Woohoo, cool. Okay, so Q is a point on AC such that PQ is parallel to AB. Determine the equation of PQ if P's coordinate, okay, so PQ, if P's coordinate is 3/4, 1. So they are looking for the equation here. So do I have perhaps AB's? Let's just see. No, we don't have the gradient. Okay, so we can work with the gradient of AB. So the gradient of AB, I'm just going to do it here so that we all can see the picture, is change of y over change of x. 2 minus 2. 6 minus 8 is -2, and so it's -1/2. Is it going downwards? Yes, it is. So it could be, or it should be, a negative, at least a -1/2. Now we know that QP, the gradient, will also be -1/2. Okay, so now I'm going to go back, and the equation for PQ is y is equal to a -1/2 x plus c. And now we can replace the P coordinate there as y is 1 and x is 3/4 to find the full picture of that equation. So -1/2, -0.5 times 3/4 gives you 1 minus, is equal to -3/8 plus c. So c is equal to 1 plus 3/8. 1 plus 3/8, which gives you 11/8. Okay, so the equation there is y is equal to -1/2 x plus 11/8. And 11/8 is 1 and something. So let's just go see if that equation there, it will go through. If that part over there is 6, there it goes through. We haven't really worked that out. But P is 1. So can you see if the y value is 1? This one is a little bit above the y value, which makes it a little bit bigger. So it seems that it's right. Okay, the next question. Determine the length of PW if W's coordinate is 23/4, 1. Okay, so we don't care about that. We've just been given W's coordinate, and I just want to write down P's coordinate again. I'm going to go with this one here, which were given there, 3/4, 1. And the distance, okay, sorry, I just quickly Aiden came in here. So you wanted to quickly, Aiden, if you hear this, you must press like on my video. Okay, all right, so the distance is the square root of the two x values subtracted. So the two x values is 3/4 minus 23/4 squared, and the two y values subtracted squared. Okay, so that would give you 3 divided by 4 minus 23/4 squared, which gives you 25, the square root of 25, and that just gives you 0. 1 minus 1 is 0. 0 squared is 0. Square root of 25 is 5 units. Okay, well done. Now they say, is ABC a right angle? Show by means of calculations and give a reason for your answer. ABC. So let's just go back here. ABC. So over here, they're asking if that is a 90-degree triangle. So what can we do? We can either prove it with our distance of the two with Pythagoras. So if you had to say AB squared plus BC squared is equal to AC squared. Another way of proving it, which is maybe an easy way, is finding the gradient of AB and seeing whether the gradient of AB times the gradient of BC gives you -1. Okay, so I'm going to go with that one. Did we already work out the gradient of AB? We did work out the gradient of BC, which we saw as, let me just quickly make sure, here, 4. So because we've proven it already, we can just say the gradient of BC is equal to 4. And then the gradient of BC, I don't think we've worked out yet. Okay, so I'm just going to do it over here because it's hard to go up and down. So the gradient of BC is the change of y over the change of x. I think I've worked it out somewhere. If I have, sorry. Oh, it's such a hot day today. Okay, so the gradient is 10 divided by 2.5. No, man, I've worked it out already. Which also gives you 10 divided by 2.5 is 4. Oh, sorry, no. This is BC that I've worked out already. I'm working with AC, the gradient of AC. And I don't, sorry, AB. AB. I ma'am, come get with it. Then the gradient of AB, let me do it down here as well. So it's the change of y, AB. So 6 minus 8 over 2 minus -2. 6 minus 8 gives you -2 over 4, which gives you -1/2. Now let me just quickly see something, sorry. Okay, it does give you -1/2, oopsie, -1/2, so the gradient of AB is -1/2. And then they say, is triangle ABC a right angle? Show by means of, so you can say gradient of BC times gradient of AB does not give you -1, thus triangle ABC, I wouldn't put a little cuppy on, sorry. Or you can say, yeah, so triangle ABC, not a right angled triangle. Lastly, give the coordinate of D so that ABCD is a parallelogram. ABCD, so D will sit somewhere over here, and so that they are a parallelogram. So remember, again, how did I get from the X value? Maybe I should just clean up here a bit. Let me just do that. Everything around here, otherwise we're going to get confused. Okay, so that I can show you nicely. Okay, so D will lie somewhere over here, and we want to get his coordinates. Okay, so what did I do to the y's here? How did I get from 6 to negative 4? I had to subtract 10. Am I right? 6 minus 10 gives you negative 4. So what do I need to do to this y value there, 8? I need to also subtract 10. So the d coordinate here, the y part, will give me negative 2, because 8 minus 10 gives you negative 2. So now how did I get from 2 to negative a half? 2 minus 4.5, no, yeah, 2 minus 4.5 gives you negative 2.5, sorry, 2 minus 3.5 gives you negative a half. So I'm going to subtract from that one. To get to that one, I'm going to subtract 3.5. So I do need to, I need to do the same with the negative 2 minus 3.5, which gives you negative 5.5. Okay, so do you remember how to get those quick and easy? You could have also gone this way around. How did I get from 2 to negative 2? I subtracted 4. So negative a half minus 4 gives you negative 5.5. How did I get from 6 to 8? I added 2. So how do I get from negative 4? I add 2, which gives me negative 2. So it's perfect. Okay, so D's coordinate is negative 5.5, negative 2. As so. All right, these questions take long, hey? Sorry. Okay, in the diagram, P, R, S, T, and they are the vertices of a trapezium. So we know that the opposite sides here are parallel. One pair of opposite sides are parallel. RS, and and PR cut the y-axis at D over here and C respectively. Okay, PT and RS cut the x-axis at E and F respectively. Okay, so they do cut there. Those are the coordinates of the x-intercepts and the y-intercepts. The diagram is not drawn to scale. Okay, write down the equation of PR. So y is equal to, because this one is 5 over there and that one is 5 over there, we can take it that it's a straight horizontal line. So y is equal to 5. Okay, it's one of those special lines that just goes straight like this. Calculate the gradient of SR. So SR over here. So the gradient is equal to the change of y over the change of x, change of y. So it's negative 7 minus 5 over negative 3 minus 3, which gives you negative 12 over negative 6, which gives you a positive 2. And it is an increasing line, so it makes sense that it should be a positive. Calculate the coordinates of D over here. Okay, so now we've got the gradient of SR. We just need to go and finish y is equal to 2x plus c. Its full equation. So I'm going to replace r over there, which is 3, 5. And the x value is 3. And then you can get the y-intercepts, which is 2 times 3 is 6. 5 minus 6 gives you negative 1. So does it make sense that this d here is negative 1? Yes, it does, because there's negative 3. But remember, it's not drawn to scale. Okay, so, but they told me calculate the coordinate of d. So very important. Always go back to your question. Just make sure that you've answered the question. Determine the equation of the line perpendicular to SR going through D. SR going through D. So they're talking about a line going perpendicularly through here. So what do we know of two lines that are perpendicular to each other? We know that their gradients are times together gives you negative 1. So if the gradient of SR is equal to 2, the gradient of a line perpendicular to that would be negative a half. And it goes through D. So it's going to be y is equal to negative a half x minus 1. Okay, it is given that TS is 2 square root 5. Determine the value of K. So K over here is a y value, is the y value of that coordinate. And they are talking about TS. So let me just write down, again, like I always do, coordinate T, which is negative 5K. And S as well, which is negative 3, negative 7. Okay, so if it is given that TS is that, determine the value of K. Okay, so the distance of TS, so the distance of the two x values subtracted, squared, plus the two values of the x or the y, whatever you haven't done, squared. Okay, so it's going to be, let's do the x's first, minus 5 minus 3, and k minus 7. Okay, and we know that it's 2 square root of 5 is the answer. So I'm going to replace it in there. Negative 5 plus 3 gives you negative 2 squared, gives you 4, plus, and then this k plus 7 squared. So k plus 7 squared. Okay, so now I first want to 2 square root of 5. I just want to quickly see something. Okay, so I'm going to carry on. And I want to simplify this. 4 plus, and because it's a plus, it's not going to hamper or change my sign. So I can just go ahead and leave the brackets, leave it off. K squared is k squared. Plus 7 times k times 2 is 14k, plus 7 squared is 49. 2 square root of 5 is equal to k squared plus 14k plus 53. Okay, so now I could have done this in the beginning as well. I know that. I'm going to square, oopsie, sorry. Square so that cancels out, and 2 square root of 5 to the power 2 gives you 20, plus 14k plus 53, and then I've got k squared plus 14k, and then 53 minus 20 is plus 33 is equal to 0. Then we have to factorize. They are both the same. They're both positive. So 11 times 3, and 11 plus 3 gives you 14. So k is either negative 11 or k is negative 3. So now we need to go look where that coordinate was lying. Okay, sorry, it was lying over here. So because the y value here would have been somewhere, the y value, let me just quickly have a look here, is somewhere there by D. We can only take it that k is going to be negative 3. Let me just quickly see what's going on. Okay, and that's why perhaps they were so explicit to say that the diagram was not drawn to scale, because over here it looks like it should be smaller than negative 1, but we do know definitely it's not below here, so it can't be negative 7, or it can't be bigger than smaller than negative 7, sorry, bigger than negative 7, so it should be k is equal to negative 3. Okay, then with number F, they say to you, find the coordinates of P if k is negative 3. So luckily with this, we can see that luckily I got k is negative 3. which makes sense. Remember, the teacher will tell you as to not create too much follow-up and your answers being ridiculously funny. She tells you halfway somewhere, okay, but actually you should have got K as -3. So luckily we've got K as -3. Now we can move on positively. If you got something different and the teacher says, look here, this should have been, or this should be that, or use this as this, then if you don't have that, go and re-look at that question and just see what, maybe you made a mistake. Okay, then they said you find the coordinates of P. Okay, if here T is -5, -3. Okay, so what we do know is we know that here they share the same Y value because they're all on a straight line. So I've got X and 5 over there. What else do I know? I know that these two have the same gradient. So maybe if I work out, I might have worked it out. I'm just going to do it again. SR's gradient, which is change of Y over change of X. I have worked it out. I remember now. But let's just do it again. -12 over -6. So SR is equal to 2. We can use that and know that this gradient is y is equal to 2x plus c. I just want to quickly make sure the gradient. Okay, so no, I'm not going to go that route, sorry. Perhaps you could have. There's so many ways of doing this. So I know the gradient of PT will also be 2. So the change of y's -3 -5 over change of x -5 -x should give me 2. Okay, so let me just show you. If I start here, -3 -5 over -5 -x should give you the same gradient because they are parallel. So -3 minus another 5 is -8 over, sorry, I'm going to equal it to 2 times -5 minus x. -10 minus 2x. So 2x is equal to -10 plus 8, which is -2. So x is equal to -1. And does it make sense here that x is -1? Yes, it does. Okay, so P's coordinate is -1, 5. Okay, I'm sure you could have worked it out somewhere else. Okay, but that's the way I did it. So P's coordinate is -1, 5. Then they say to you, if M is a point on the Cartesian plane such that RSTM is a parallelogram. Okay, so very important parallelogram. Calculate the coordinates of M. RSTM. So let me just erase everything around here. I hope that's okay. Okay, let's go put in that point. R, S, T, and M will be, can you see, likely over here somewhere, so that these two are parallel. Sorry, they're not so parallel, and that these two are parallel, which they are. Okay, so how did I get from -7 to 5? So for the y values, I need to add 12. So for the y value, and this one was t -5, -3. So now from -3, I need to add 12. -3 plus 12 gives you 9 over there. Then with a different color, let's see how we got the x's. From -3 to 3, I added 6. So the x value here, if I add 6, I should get a 1, which makes sense that it sits, sorry, it should have sit a little bit higher up. So it makes sense that that is 1, and that there should be somewhere 9. So M is 1, 9. Okay. Yay, people. This video is taking forever and a day. Okay, let's look at question 4. It says, given below is a pyramid with a square base. So square base, which means all the sides of there will be the same. And in this instance, it tells me that it is 8. Okay, and with a square base and h over here, baby h, is 14. So if I have a triangle and I just draw it right side up, can you see if I work with only half of it, that this side would be 4 because half of 8 is 4, and the baby h, the height is 14. Sorry, not there. The slanting side, can you see? So can you see I can find big Papa H with Pythagoras? Okay, so 14 squared minus 4 squared gives you 180, and the square root of 180, and it says leave your answer in simplest third form. Okay, so h is going to be h squared, there's my big h squared plus 4 squared is equal to 14 squared, and that is because of Pythagoras. So h squared is equal to the square root of 180. So h is equal to, let me just make sure, sorry, I mustn't put that square root on there. So h is going to be 6 square root of 5. That is the simplest third form for h. Okay, and then they say if the formula for the volume is V is equal to a third of the area of the base times the height, find the volume of the pyramid. Round off to 1 decimal place. So the volume is equal to a third times the area of the base, and the area of the base is 8 times 8, or 8 squared, times big Papa H, which is 6 square root 5. So the volume is equal to a third, 1 divided by 3 times 64 times 6 square root of 5, which gives you 286, rounded off to 1 decimal place, so it's comma 2, and it is in centimeters, and because it's volume I have to put a 3 cubed. Okay, not so hard. Calculate the surface area of the pyramid. Okay, so now if you've got the full triangle, it would be, the base is going to be 8, and the height is is 14. Okay, and remember it's got how many rectangles? If you look over, sorry, not rectangles, triangles. So it's going to be 1, 2, 3, 4 of them. So 4 triangles plus the base, which is 8 times 8. Okay, so the surface area of it is going to be base times height divided by 2. All of that I'm going to times by 4, and then I'm going to add the area of the base. Hope that makes sense. So the base times height divided by 2 gives you 56 times 4 plus 64, which gives you 288, and again centimeters squared because it's the surface area. It says to you in the diagram below, B is the midpoint of AC, so over here between there and there is the midpoint, and it is given that TB over BS is equal to 3 over 2. So what that means is that TB over here, if it is I don't know, however many units, this one will be 3 times and this one would be 2 times. So it will be in ratio 3 to 2. Okay, so it tells you determine the length of TB. Okay, so first of all, because they gave me the midpoint, I think I'm going to start with that. So the midpoint of AC is equal to the two x values added together divided by 2, and the two y values added together divided by 2. So negative 1 plus 5 is 4, 4 divided by 2 is 2, and 10. Okay, so that coordinate there is 2, 10. Now the next step is we can work out BS. It's not bull dust, it's just BS. Okay, so we can work out the distance of BS. Okay, and the distance of BS is the two, let me do the x values, the y values, so 10 minus 10 squared, plus, sorry, the two x values subtracted from each other, doesn't matter which order. 10 minus 10 is nothing. 5 minus 2 is 3. 3 squared is 9, which gives you that it's 3 units long. Okay, so if BS is equal to 3 units, then, so if let's do it like this. TB in the ratio to BS is 3 to 2. So if BS is 3 units, what would TB be? So 3 divided by 2 times 3, if you know your pirate method, and it gives you 4.5 units. Thus, TB is equal to 4.5 units. Okay, I hope that makes sense. Let's just see, is the midpoint of AC given? Determine the length of TB, and we've got the length of TB. So again, every time you've done a sum, just go double check, did I answer what they were asking? Hi grade 10s, thank you so much for watching. This is me in my class. Just thought I'll give you a bit of insight. Behind me I've got 2 little kiddies. That's really my own. I always refer to all the kids I teach as my children, but I have 2 that is my my own 2 children, and they love drawing Pokemon pictures. So just thought I'll give you a bit of insight. This is me in my class. While the kids are writing exams, I'm busy making videos to help them through it. So I hope it's going well with your exam, and I hope that the videos are helping. If you enjoyed this video, please watch the next one, which is also on trigonometry, the daddy of paper 2. And I really hope that all your exams are going very well. Thanks for watching. Cheers. Bye.